Thank you so much. It's an absolute delight to be here. And one of my many kind of pleasures has been over the last few years going through the history of technological change. I did a book called 50 Things That Made the Modern Economy. I did a BBC series called 50 Things That Made the Modern Economy. Then the BBC decided they wanted another 50, so it turned into 100 things that made the modern economy, and there was a second book. And the point is not to try and sell books to you, although books are a great technology, actually. Feel free to buy books. The point is not to sell books to you, but the point is to tell you a little bit about where I'm coming from. I'm not an expert in insurance. I'm not an expert in artificial intelligence. I'm certainly not an expert in the future. Remember, I'm an economist. We're terrible at predictions about the future. But I do know a little bit about how previous technologies have unfolded, and in particular what their consequences are have been. And I've noticed one thing, or I've noticed a few things over and over again, in particular, a tendency that we have to get things wrong when we're thinking about technological change. And I'd like to talk to you about two particular things we get wrong over and over again, and maybe how we can think in a more rigorous and, who knows, possibly even accurate way about the technological change that's coming towards us today. Now, I wanted to start, I thought, what would be a really kind of original idea that no other speaker at the conference would use? I thought, I know. I'll put up a screenshot from a film from the 1980s that was set in the future, because no one else is going to do that. Actually, I really enjoyed Adrian's remarks. I think I'm going to draw some slightly different conclusions, hopefully complementary conclusions. My choice of film, slightly darker, of course, is Blade Runner. Blade Runner, the film came out in 1982, set in a post-apocalyptic dystopian society where the struggle for survival is real and people are exploited every day by rapacious corporations. 2019, by the way, for those of you not keeping track, is when Blade Runner was set. And Blade Runner, of course, is a film with lots and lots of views about technology. It portrays lots of technologies. It makes lots of mistakes. And I want to talk particularly about the mistakes in general. I want to talk about the specific lessons we learn from those mistakes. I think they're very instructive. So Blade Runner, for those of you who've seen it, you must see it. It's a great, great movie. It portrays a world of flying cars, portrays a world of space travel, although space travel is not particularly important in the plot, apart from one epic monologue from Rutger Hauer. It portrays a world, very importantly, in which you have artificial intelligence. You have synthetic biology. You have these people called replicants who are both biologically and intellectually indistinguishable from humans unless you subject them to an expert battery of tests, unless you have the right equipment and the right experience. You cannot tell the artificial humans from the real humans. It also portrays a future in which smoking is still really sexy. So this is one of these artificial humans. Her name is Rachel. She doesn't know she's an artificial human. This is a phenomenal technology we're describing here. Incredible sophistication. 2019, artificial life, artificial intelligence, indistinguishable from human intelligence. Our heroine, Rachel, is so beguiling that our hero, Deckard, whose literal job is to find and kill rogue replicants, basically falls in love with her, or certainly has strong feelings for her one way or another. And what do you do when you have those feelings for somebody? Well, in the world of 2019, you go to a bar, you get drunk, and you literally go to a payphone on the wall, pick up the payphone receiver, and ask her out on a date. This is what he does. I mean, obviously, it's the future, so the payphone is a video phone, but otherwise it's exactly like the payphones of 1982. You know, it's even got the graffiti on it. And naturally, he's drunk and he's kind of not really a welcome advance, and she hangs up on him. So some things don't change. But this is interesting. This is a portrayal of a world in which some parts of technology have become so sophisticated as to really defy belief, that almost indistinguishable from magic. And some technology hasn't really changed at all. And I think this is very, very common. So what is behind this sort of error? Two things. I'll cover both things. Number one, we get absolutely hypnotized. When we're talking about technological change, we get absolutely hypnotized by the coolest, most sophisticated, most complicated, whatever it is that will be most bewildering to our grandparents. That is the thing that we think of as being the most consequential technology. And I would like to argue that the most consequential technologies are often not at all like that. They are often not at all the magic boxes of tricks. So let me give you an example. And this technology is often cited as the most important technological invention of the last 1,000 years. And generally when that statement is put forward, people are like, yeah, that's about right. Any guesses as to what it is? The most important technology of the last 1,000 years? I like the washing machines. I like concrete. You've read my book. It's the printing press. The movable type printing press developed by Johannes Gutenberg in what is, I mean, it wasn't even Germany back then. It was so long ago, but what we would now call Germany in the city of Mainz. And this is a Gutenberg Bible, unbelievably beautiful, beautiful object. Just to be clear, the drawing, the color drawing is hand illustrated, but the black text, although it looks as though it must be handwritten, it looks like the kind of thing, you know, it looks like proper sort of organic, artisanal, monk-written text, you know, the kind that you'd have served up by a hipster in Hackney. It looks like it must be handmade, but it's not handmade. It's printed. These incredible, dense, black columns of Latin text are printed. And yeah, sure, this is a very, very consequential invention. But why is it consequential? It's not consequential because Gutenberg is really doing anything new. Writing was not new. Writing's about, it depends how you measure it, about 5,000 years old. It was the first writing, by the way, spreadsheets. Score one for the nerds. We will talk about spreadsheets later. The first writing goes back to the city of Uruk in Mesopotamia. It's now what is now Iraq. That's a new technology. And that does a thing that you could not have done before. You've basically freezing something that previously was evanescent, speech. And you capture it and you record it. And some of the speech that was captured and recorded could be captured and recorded, and we can still read it 5,000 years later. That's a new technology. That's a miracle. Gutenberg's not doing anything new. He's just doing the old thing cheaper. And I think that's a very important distinction. A lot of the technologies that change the world don't really do a new thing. They do the old thing in a much cheaper way. And when something becomes incredibly cheap, then it is cheap enough to change the world. And I think a really important point here is Gutenberg's invention is no good whatsoever without a complementary invention. We see the text. What's it printed on? It's printed on paper. Some of the original Gutenberg Bibles were printed on vellum, which is basically it's sheepskin. I did the maths, because doing the maths is something I like to do. It turns out that if you want a print run of, say, 4,000 books, so the kind of print run you might need to make the whole exercise worthwhile, if you want a print run of 4,000 Bibles, that's 250,000 sheep. Okay, it's not going to work. So there's no point in mass-producing writing unless you can also mass-produce a writing surface. But fortunately, this Chinese invention called paper had come first to the Middle East, where they had paper and mass literacy, where they didn't have print. Then it came to Italy, to Fabriano in Italy, where they still make incredible paper. and finally migrated its way up to Germany. And only a few decades later, when paper has started to become available and people are not really sure what to do with it, Gutenberg invents the printing press. Oh, right, you have a complementary invention. You've got mass-produced writing. You've also got a mass-produced writing surface. Suddenly, you're off to the races. And, all that good stuff, the transmission of knowledge, incredibly bloody interreligious wars, all that stuff that the printing press triggers, that all happens. So it's useless without cheap paper. We could call this, if you like, call this the toilet paper principle. Once something is so cheap you can wipe anything you like with it, it is cheap enough to change the world. So you might say, well, Tim, that's okay, fine, that's one example. Can you give me some other examples? Well, sure, I can. So Abraham Lincoln, in the Homesteading Act of, I can't remember, 1863 maybe? Anyway, Lincoln signs the Homesteading Act. He's trying to shift the center of gravity in the United States from the South to the Midwest. He basically says, anybody, man, woman, freed slave, anybody who goes west and who puts a fence around a piece of land and basically says, okay, this is my land, and improves that land for 5 years, that land is theirs. There's a certain acreage that you can lay claim to. That was the law. Trouble is, if you go to the Midwest, a lot of grass, not a lot of wood. So what are you going to build the fences out of? You're trying to lay claim to land. And fencing is a known technology, but cheap portable fencing is not. But very quickly, a gentleman called J.F. Glidden of DeKalb, Illinois, invents barbed wire. This is barbed wire. These gentlemen, you may think you know who these gentlemen are. They look rather threatening. They are part of the wire-cutting wars in Texas. Because basically what you had is a whole bunch of people showing up and putting up barbed wire around property and saying, this is mine, and a whole bunch of other people saying, that's not yours, and trying to take the barbed wire down again. And several people got killed, that sort of thing. I mean, who would have thought that people would basically come across some random resource and suddenly say, actually, this resource is ours, and then a whole bunch of other people will get crushed? Would never happen today. Yeah, I mean, okay, fine. The resource today is data, but some things don't change. The reason barbed wire, again, was so revolutionary is not because nobody knew how to make a fence, but because nobody knew how to make a cheap portable fence in a world where you don't have much wood. And J.F. Glidden's invention was, he came from DeKalb, Illinois, by the way, same place as Cindy Crawford. So that's news you can use. J.F. Glidden's invention so rapidly adopted that in between him originally applying for the patent and over the next 10 years, there was enough barbed wire produced to encircle the world 10 times over. So that's, people talk about how rapidly ChatGPT has been adopted. Barbed wire, pretty enthusiastically adopted as well. One of the barbed wire salesmen, by the way, a guy called John Warren Gates, described it as lighter than air, stronger than whiskey, and cheaper than dust. Cheaper than dust. That is what changes the world. Okay, fine. But you'll say, sure, but these are all old inventions, Tim. Let's have a new invention. Sure, let's have a new invention. Let's talk. We've already heard Adrian talk a little bit about solar power. Let's talk about solar power. So this is the cost of solar power over the last 50 years. And as you can see, it's coming down, 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 down. Now, I've called this the IKEAization of solar power, because fundamentally, the reason solar panels are getting so cheap is because of mass production. People are just getting very, very good at producing them, which is driving down the cost, and economies of scale in installation. So designing solar panels so they flat pack, designing solar panels so you can stick them on a roof in an afternoon with some simple tools rather than that take all week. All of these things are driving down the cost of solar power. And by the way, those of you who are looking carefully at this diagram, I've written it with tiny, tiny numbers, so you can't quite see. This is actually a log scale. If you look at a regular scale, the cost of solar power has actually fallen like that. So this scale is basically just showing in percentage terms. It's getting cheaper and cheaper in percentage terms, but the real drop in price is absolutely incredible. And again, it's the same basic technology. The solar panels are basically the same as you stuck on your calculators in the 1980s, or they stuck on satellites in the 1970s, because basically there was nothing on Earth that you would want to power with a solar panel, because they were so expensive. But okay, up in space, maybe we can use them. And now they're just absolutely everywhere. So again, cheaper than dust. When it gets cheap, it changes the world. And one more example is the shipping container, often regarded as one of the most consequential inventions of the second half of the 20th century. It's a really simple invention. It's a great big box. The shipping container really transformed the world, because before the shipping container, what you had is you basically had loads and loads of people at every port who would go in the ships and carry all the stuff off the ships, and then they would load all the stuff on a train, and the train would go somewhere, and a load of people had to take the stuff off the train and load it onto a truck, and the truck would go somewhere, and finally you got some people at the final destination who take the stuff off the truck. And the genius of the box is just like, why don't we just put all the stuff in a box and get a crane and take the box out of the ship and put it on the train, and then take the box off the train and put it on the truck. And that made shipping massively cheaper, massively more reliable, massively faster. One of the things that I think is important about it, and this leads into the second point I want to make, is that it was a systemic change. Like, people had thought of putting a bunch of stuff into boxes before, but the person who made this work, who was an entrepreneur called Malcolm McLean, realized it's not as simple as just like, oh, why don't we put everything in boxes? You actually need the ships to be built to accommodate the boxes. You need the cranes on the docks to accommodate the boxes. The trains need to be designed to accommodate the boxes. The trucks need to be designed to accommodate the boxes. The contracts with the labor unions, who are not happy about any of this, need to be figured one way or another. The regulations which ban one company from operating a train line and a shipping line, the regulations have got to be renegotiated. All of this stuff has got to be dealt with. The whole system has to change, otherwise this can't work. And that gets us to the second point that I want to make. The thing that we get wrong about technology over and over again is all about systemic change. But to make that point, I wanted to show you a short video, because if you think there's nothing more ridiculous than talking about a movie from the 1980s set in the future, wait until I show you a television show from 1967 called Tomorrow's World. And I would like to show you a short film, hopefully we'll have a little bit of sound, that will show you what the office of the future looked like in 1967.
What nice people. Ah, my office. The perfect office. Perspex desk, no in tray, no out tray, no phone, no filing cabinets, no clutter. Quiet, cool, very efficient. I need never get out of this chair. That'll be nice. No distractions. Just me and the work. Alone and efficient. Alone. Wonder if anybody wants me. Nobody to ask.
Messages.
Well, BJ39 will know. After all, it works for me. I don't even have to go to it. Much better than a human being. Tireless and efficient. Anything I want, it brings.
I mean, basically accurate, right? I love the robot BJ39. Brings you your TV screen. Okay, so what is the one thing they got right? I think there's one thing they got right, they absolutely nailed. One thing they got right is when you sit down to do some work, it will take you 10 seconds before you press a button to check some messages, to distract yourself. That they got, everything else wrong. And no one has corner offices anymore. People don't have robotic desks. People don't have desks without computers on them. People do their own typing. They don't have typing pools. I realize sexism is still a thing, but I don't think anymore we have offices where you just have acres of attractive young secretaries being obsequious and like the one man in the room is the boss. Please don't tell me I'm wrong about that. Basically, what you've got is a vision of the office of the future that has absolutely no social or organizational change in it. And I think that's important to reflect on. So remember how Malcolm McLean, when he develops a shipping container, he's not really just developing a shipping container. He's developing a whole new organizational system for logistics. When Gutenberg develops the printing press, sure, he's just developing a new technology, but that technology changes everything. It changes the way people think, it changes the way people speak, it changes religion, it changes our attitude to authority, it creates all kinds of, the library, the pamphlet, the political pamphlet, the newspaper, everything changes because this thing changes. And that, I think, is a mistake we see in Blade Runner. So you see, you are creating artificial humans, but basically everyone, and sure, people have flying cars, but basically people going out on the streets, everything looks a bit like Tokyo, only dirtier, and having noodles, and basically nothing's really changed. People are still just selling each other Coca-Cola, and it's all the same. Could that possibly be true? Could you possibly have a society where nothing really changes except more neon? And you have artificial humans? I don't think so. But it's very, very difficult to think through the implications of social change. What we like to do is we like to think about technology as being like there's this kind of box, and we've got some problem in our lives, in our businesses, or in our personal lives. And we buy the technology in this box, and we take this box, and this box basically just solves the problem, and nothing else changes. That's how we like to think of things. But of course, everything changes. Any meaningful technology is going to change all sorts of other things. So, I mean, you just need to think about the smartphone. Okay, so we start with the mobile phone, and it solves the problem of, well, telephones were useful, but what if you could carry a telephone around with you? And then suddenly we've got we've got suicide TikTok, and you're trying to block your phone from distracting you from your other phone, and I mean, it's solving all kinds of new problems. It's creating all sorts of new dynamics. It's so much more than, oh, it's a portable phone. And the consequential inventions always are so much more than a portable phone, because they change who we are, they change how we organize ourselves, they change how we interact with each other. So there's an absolutely classic example of this that I want to talk about a little bit, and I apologize. Some of you will have heard it because it's very, very famous in the history of technology, but I still think it's worth talking about because some of you won't know, and to me it's endlessly insightful. So this concerns the development of electric power in the late 1800s. So you've got the availability of electric motors, and you can buy electricity on the grid by kind of like the 1870s. And if you had asked experts in American manufacturing what the impact of this new technology would be, they would have said, well, it seems pretty revolutionary. This is an amazing new source of power. This is an amazing new way to power our factories. It is going to change manufacturing completely. And then if you go and look, I don't know, 1910, technology has been available for 40 years. That's basically an entire professional lifetime. And you look at the data, and you basically find it's not been that widely adopted, and where it has been adopted, it's been a bit disappointing in its impacts. So what's happening? Here's a picture of a factory from back in the day. late 19th century. You can see these bands coming down from the ceiling, and they're drive belts. And the way this factory is organized is basically outside, in another building, or in sort of an adjacent annex, you have a steam engine, probably coal-fired steam engine. And that's not ideal for textiles because there's a lot of coal dust. And anyway, so the steam engine is turning, and the steam engine is turning these drive shafts that go along the ceiling. And the power for everything that these guys are doing is coming down these drive belts from the drive shafts. And everything that's happening in the factory is governed by the logic of the drive shaft. So people who need more power need to be closer to the drive shaft. Everything has to run at basically the same pace. You can disconnect a piece of machinery from the drive shaft, but it's either, it's running at that speed or it's not running at that speed. And the drive shafts take up a lot of room. And what people did initially when they had access to electric motors is like, great, we'll rip out the steam engine and we'll put in a massive electric motor. And then nothing really happens. It's a little bit cheaper, maybe a bit cheaper to run. It's quite expensive to buy. It's a bit cleaner. If you're making white shirts, that's nice. Doesn't really make much of a difference. And it's only kind of in the 1920s, and this is partly because of various shocks caused by the First World War, restriction on immigration, less availability of labor, various things that entrepreneurs start trying to rethink their whole processes. The people really start to think about how to use electric power. And what they realize is, you can do something with you can do exactly the same with electric power as you were doing with a steam engine. Or you could have on every worker's workbench a small electric motor that they can run at whatever pace they want, and the power for that motor doesn't come from this big drive shaft and all these belts, which you've got drip feeding oil, and if you get your sleeve caught in the belt, you're up and you're dead, and there's all kinds of stuff going on. You don't need any of that. You take away the drive shaft. You could just have everything just comes via electric wires. That's nice. Well, hang on. Once you've done that, you can reorganize the whole factory. It doesn't need to be governed by the logic of accessibility of the drive shaft. Instead, you design the factory according to the material flow around, like what's the process? What moves from what to where? In fact, you could have an assembly line. There's all kinds of things you could do that are more efficient. But actually, it's not just that. Because once you've done that, you might think, you know what, the previous factory was all kind of crowded in around the drive shaft. We can spread out. Land is cheap. We can have a great big factory, loads of room. We can have skylights, so it's better lit, natural light. Or we can have equipment, we can have like cranes on the ceilings to help move heavy stuff around, because the drive shafts aren't there in the way. But actually, it's more than that, because every worker is working at their own pace. So we need to give them more training because they're making more consequential decisions, and we probably need to pay them in a different way. And we probably need to recruit different people. In other words, electricity is transformational. All you need to do is get in an electric motor and redesign your process and redesign all the complementary equipment and rebuild your factory and retrain your workforce and hire a new workforce and pay them differently. That's all you need to do, and then it's really effective. And so this example was discussed by the economic historian Paul David, and what he found was, we're trying to get productivity gains of, 0.5% a year or something. Be delighted with 0.5% a year these days, productivity gains. In the 1920s, American manufacturing, 7% a year. That's, you double your productivity over the course of a decade. This is the kind of thing Rachel Reeves is currently dreaming of. But that happened when the technology had already been available for 40, maybe 50 years, because it needed all of this social and organizational change. And it's not always easy to think all of that through and to see it coming. And of course, Paul Davids wrote about this in the 1990s, and actually it was 2001. It was in the wake of the 1990s. You had the World Wide Web. People were sort of asking the same question, and he was coming up with the same answer, which is, yeah, probably computers are going to make a big difference. The integrated circuit, the internet, the web, it's all going to make a big difference, but like not overnight. All this stuff takes time to really figure out how to make it work. And along came, a year or so later, along came Eric Brinjolson. Actually, no, this is published a year before. Eric Brinjolson and Lauren Hitt. Brinjolson's now super famous. He writes about AI a lot. I was following his work before he was famous. With Lauren Hitt, he published this piece in the Journal of Economic Perspectives, and they were studying the impact of technological adoption on corporate productivity. And this is like a super complicated graph, which must have been very difficult to draw in 25 years ago. But basically what that three-dimensional surface is describing is fundamentally, if you go this way, if you go up, more money. If you go this way, more computers. And if you go that way, deeper, you're reorganizing the company. It's actually, there's a measure of decentralization. And what they're basically finding is, like, if you just get more computers, you don't make much more money. If you reorganize the company, you don't make much more money. If you do nothing, that's probably not the worst thing to do. But if you really want to make money, you need to reorganize the corporation and you need to get the computers. You need to do both things. So that's and that was based on case studies of, I think, of medical insurers in the 1990s. But the point I think is quite general. You've got a new technology. You cannot just expect to get the new technology, to throw away your old thing, plug in the new thing, change nothing, and expect to really be reaping the benefits, because so often it requires a lot more than that. So, this is the point in the talk where we need to speak about AI, right? Because it's compulsory to talk about AI. What can I say about AI that hasn't already been said? Well, I was trying to think. It does seem to be an almost unprecedented technology. I should put up like a scary kind of HAL 9000 graphic at this point, right? It feels unprecedented. And of course, in some ways, it is unprecedented. In some ways, everything's unprecedented. But there's always a parallel from the past that I think teaches us something. And I wanted to talk briefly about two different technologies that in their own way prefigure AI and contrast them and draw some lessons. Okay. So the first technology was launched in 1979. And I told you this was coming. The spreadsheet, the digital spreadsheet. And again, consistent with my previous argument, okay, spreadsheets not new, okay? Spreadsheets about 700 years old. So you had accountancy, double entry bookkeeping, it's developed, actually we're not sure exactly where it's developed. It became known as bookkeeping alla Venezia, in the Venetian style. But anyway, you put together all your accounts, and one of the things you would have was this, you'd have this big piece of paper, very important invention, you'd spread it out, and you'd kind of collate all the stuff you had from your accounting books, and that would be the spreadsheet. So that's an old invention, but a business school graduate or business school student called Dan Bricklin, who'd worked in computing and then went to do an MBA, and he's looking at his business school professor doing double entry bookkeeping, and he's got this spreadsheet on the board, and he like shows how, oh, if you rub out this number and then you have to change this number and then you recalculate the whole column, and Bricklin's looking at this going, this is really dumb, I could get a computer to do this, no problem. And so he develops VisiCalc. And VisiCalc, the reason it's called VisiCalc is it's not just doing maths. There was accounting software before VisiCalc, but it's doing maths in the same way, with the same visuals as the original spreadsheet. And VisiCalc catches on really fast. Like, if you want to understand the future of AI, you could do worse than find an old accountant and ask them to talk about the world before and after VisiCalc. So there's this moment, which I think teaches us a lot about the present day. There's this moment in about 1981 where the accountants have all got VisiCalc, but the clients don't really know it yet. And so client would give an accountant, oh, we've got a rush job, we need you to do this, we're really sorry, it's really, really important, you need to recalculate the spreadsheet, da, 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 da. And the accountant would go, yeah, sure, okay, yeah, I'll get right on it, I'll pull an all-nighter, da, 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 da. Basically, type in a couple of numbers to VisiCalc, it's done, and then sit there for 48 hours and then FedEx the result overnight to the client, who is delighted. It's amazing that you managed to do it so quickly. You charge them for 3 days' work. That didn't last. But one of the interesting things about VisiCalc is it was totally ubiquitous within 5 years. Then it was replaced by Lotus 123, then it was replaced by Excel, but the same basic idea. Totally ubiquitous. It completely wiped out a certain type of accountant called an accounting clerk or accounting clerk. All gone. And the accounting clerk's job is basically arithmetic. And I'm sorry, but the computer does it faster. And so they're all gone. They're all gone. There are no accounting clerks. It's all replaced by the spreadsheet. However, the number of people working in accountancy in the United States increased substantially between 1979 and the present day. You've got more accountants than ever. And, well, why? Well, because they're doing different things. They're not doing arithmetic anymore. They're doing more creative stuff. And, who doesn't want a creative accountant? So people are starting to ask questions of the spreadsheets that they would never have asked before because it was just too expensive. You could have done it, just too expensive. So the idea of doing some financial forecasting, scenario planning, robustness analysis, what if we do this, what if we do that, let's project it, let's change the discount rate, what if we change the assumptions, you do all this kind of thing, very, very interesting, much more creative, much more fulfilling, better paid, thank goodness for AI. The robot accountant is here, he doesn't look like Arnie, he doesn't look like C3PO, looks like this. There is another slightly more recent technology that gives us a slightly different perspective on AI, and that technology is Jennifer. Jennifer, this is Jennifer, but just to be clear, Jennifer is not the woman in the white T-shirt. Jennifer is the voice in her ear. And Jennifer is basically some software connected to a headset that directs workers around warehouses. And I should say this photo is now about 7, 8 years old. I'm sure warehouse technology is changing very, very fast. But what Jennifer would do was, Jennifer knows where all the stuff is. Jennifer knows the optimal path to get to the stuff. And Jennifer can keep track of the order. And Jennifer doesn't take up your hands. You could look at the items. You don't need to kind of tick off some list because Jennifer's doing it all. You just tell Jennifer when it's done. So Jennifer might say, walk to aisle A13. Go to shelf 6. Take 5 copies of Tim Harford's book, 50 Things That Made the Modern Economy, off the shelf. Take 5 more copies of 50 Things That Made the Modern Economy off the shelf. Take 3 copies of 50, because Jennifer doesn't trust you to count to 13. It won't tell you to do more than 5 at a time, because humans make mistakes. So basically, Jennifer has taken, and people just fall asleep dreaming of Jennifer talking to them. So, because Jennifer doesn't need your conscious brain. Jennifer needs your eyes and your hands. Jennifer turns warehouse workers into kind of flesh robots. It's very, very difficult to build a robot to pick up a random amount of stuff in an Amazon warehouse or any other warehouse. Very, very difficult to do that. But Jennifer basically says you don't need to think. You just need to look and grab. So the spreadsheet took a job that was already quite high status, quite interesting, quite well paid, and made it more high status, more interesting, better paid. Jennifer took a job that was already fairly low status, pretty dull, and not very well paid, and just made it worse in every conceivable direction. What does that tell us about the future of AI? All it tells me is that I think we have a choice. And when I say we, maybe not you and me, maybe somebody else, maybe it's Sam Altman who has the choice. There's a choice to be made about what sort of technology we embrace and what sort of technology we try to regulate or fight against. But one thing I'm absolutely sure of, if it changes the way we live, it'll do that for 2 reasons. 1, because it triggers social and organizational change. And 2, because like barbed wire, it's cheaper than dust. All the great inventions are. Thank you so much for listening. Thank you. we have a time for a question or what?
We do, yeah, we do. We have mics out in the audience. Do we have anybody with a question? Here we go, front row. Thank you.
I think there's a microphone coming. It is coming with great speed.
She's running up the side.
I figured out what happened. Everyone else saw what happened. I only heard.
I'm just glad this whole thing
I've just decided that this thing was probably not part of the design. It's great. Anyway,
Yeah.
It's cool. It's cool.
Don't
Right.
worry about that
yeah.
team.
Sorry.
Hello?
Yes?
Thanks. Thanks very much for your talk. I have the following question. If making remarkable changes in this way would require both adopting technology and organizational reorganization, the stakes are quite high because you can get it very wrong. So what's the responsible way to try to make kind of home run level changes without putting the whole organization at risk?
So how do we responsibly make changes when the stakes are so high and the risk of things going wrong is so great? I think it's a great question. I don't know if I have a great answer. I mean, I literally wrote a book about change called Adapt. The book itself is now 15 years old, and I don't know how, the psychology of human adaptation hasn't changed, but the technology certainly has. Some of the points that I make there are that it's tempting not to pilot stuff. It's tempting to just charge in and do something big. And I think the reason why that's tempting is because, well, most people are worried, oh, I've only got so long in my job, I need to make an impact, I need to do something fast. Pilots feel wasteful, pilots never quite work, there's always a problem. And so we often hesitate to do the small thing that's going to kind of generate information. We like to tell ourselves, oh, this will definitely work. And if it will definitely work, then why would you dabble around the edges? Why would you just do the small thing? If instead you have this more experimental mindset where you go, well, this could be interesting, this could be cool, it might work, it might not, we don't really know, then you're much more open to little experiments, to little pilots, to sort of training wheels. Sometimes they're called skunk works, so a part of the organization that's kind of working on cool things. Or just what's sometimes, sometimes called bottom-up innovation, where you're basically trying to encourage your customers or people at the coalface of your workforce to come up with ideas and generate brilliant stuff. But I think it's that experimental mindset that's really important. And it's not always straightforward because often we're talking about platforms where the platform works best if kind of like everything happens all at once. But I think that the gains from experiment and the gains from listening to what is actually happening at the interface between the customer and the organization, I think, are incredibly important. There's a wonderful, we've got time for it.
Yes,
so there's a wonderful little example of this in the Second World War, the preparation for D-Day. The Allies invented this kind of floating tank called the DD tank, dual drive. And the idea was, if you drive boats up to the beaches, then the boats are easy targets. And so, what if you could let the tanks off and then float the tank ashore, and then maybe they hit a tank, but you don't hit all the tanks on a boat. So they have these ideas of these floating tanks, and kind of a cool idea, but actually you didn't really need them. The boats worked just fine. If you wanted a tank boat hybrid, then maybe you just put a tank on a boat. Which they did in the Pacific, or you just have these ferries and they bring the tanks ashore. It worked fine everywhere else. The floating tanks, they all sank, and literally all sank. Disaster, because the weather was not so great. So that's an example of somebody well away from the front, well away from the action, basically coming up with a really big idea and going, okay, let's roll this out, and we've got one chance, and it didn't work. The Allies then, but anyway, D-Day worked, as you know. The Allies then got bogged down in the Normandy hedgerows. They had these incredibly dense networks of hedgerows. Turned out to be incredibly difficult to fight through. You couldn't take a tank through them. If you took infantry through, they'd be mown down by machine guns. Total disaster. Then the guys on the ground were like, well, we need some kind of bulldozer to take these hedges out. Well, we kind of got tanks. They're sort of half a bulldozer already. Well, what if we kind of put like massive sharp bits of metal on the front of tanks? Well, where's the massive sharp bits of metal? Well, there's a whole bunch of, back on Omaha Beach, we came through the sharp bits of metal. The Germans kindly left us loads of really big pieces of sharp metal on the beach as part of the beach defenses. So they went back, pick up the metal, weld it to the front of the tank, charge it at a hedgerow, destroys the hedgerow. Wow, this works. So, it just totally transformed the Allied advance. So you had these two different examples of a technology where, I should have put this story in the speech, shouldn't I? It's kind of interesting. One where somebody basically a long, long way away from the action comes up with this great big one-shot idea, and maybe it would have worked, but it didn't. And the other where you've got the people who are absolutely facing the problem, a problem that nobody anticipated, these hedges, and they're like, right, we need to figure out a really simple, basic, inelegant solution right now, and they did. So that's how to do it.
Thank you. Any last question? All right, I think that's time. Thank you.
Thank you very much, guys.
Tim.